Welcome back to Java with Miyoshi. I want to talk today about math. So, in Java, and you have these math operators, and we have multiplication, division. This new guy here, that many of you may not remember or notice unless you programmed before, that's called the modulus operator, plus and minus. We also have these compound operators, which is plus assign the value, divide assign the value, modulus assign the value, plus assign the value, and minus assign the value. And of course, if we have just a single equal sign, that is called assign the value, is assign the value. And I mentioned it before, but I'll talk about that a little bit more as we go along. Then we also have these guys here called plus plus and minus minus. And what they do is they take a variable and they'll either add one to it or they'll subtract one from it. Okay? So with these compound operators, if I have something like a plus assign the value 6, that's if I have a set to value 7 in the beginning, then 7 plus 6 is 13. So get a little bit ahead of myself, but let's just see what happens here. So as we talked about a little bit before, when we assign a variable, or we declare a variable by saying int a, for instance, that declares the variable and that says, hey, take set aside some memory and call it a. We don't want to know what that memory location is. We just want to associate it with this letter a, or whatever variable name we're using. And then this guy here, the equal sign, that says assign 7 to a. In other words, stick 7 into the memory location associated with a. Now, since we don't want to say put 7 in the memory location associated with a all the time, we just say a is assigned the value 7. Try not to call that equal sign, a single equal sign, just equals, even though that's what it is in math, because we have a different operator when we want to look to see if something is equal. This guy does assign the value. It makes the 7 be in where a is, the memory location associated with a. Okay? So, here I have a short little program here. I have int a is assigned the value 7, comma b is assigned the value 3, comma c. So this declares and initializes a and b. Initializing just means that we're putting some value into those guys right in the beginning or whenever I happen to do it. And I just declare c. I just say, hey, save some memory location for c. And then I declare and initialize x and y, stick 7.0 and 3.0 in there, and I just initialize, or just declares z. So then I have over here, you see the memory location associated with those guys. I have a and b, they have 7 and 3 respectively. I have x and y, and they have 7 and 3 respectively. And c and z have nothing in them. Notice also that these guys here are going to be integers, so they would have more memory or less memory associated with them than the floats do, because the floats have they have the decimal values with them, or what I like to say is they have a fractional part of a number in them, but integers do not, just like in math. So one of the things I kind of assume here too is that not everybody, or that most of the folks watching my videos are people who have been in my class, and if you've been in my class then you've seen all these things before because you programmed in another language already. So when I forget some of those things, maybe if you write some comments, I will come back and fill in some of the blanks, but for now I'm just trying to get things going for you here. Okay, so here's a little program, and all I've done is I've looked at each of these operations in terms. So I have z is assigned the value x plus y, and all that does is just like you think, it takes x and adds y to it, and that is 10, and then it's going to stick 10 into z. So I would have 10 in there after this operation is done. Then in this one I do x minus y, and I stick that into z. So z is assigned the value x minus y is how I read that, and I take 4 now, it's going to get stuck into z. And then z is assigned the value x times y. Well, that's going to be x times y, so 7 times 3 is 21, and that's going to get stuck into z. Now here I left this comment out here. I have z is assigned the value x divided by y, and that again is going to be just what you think it is. So if I have x divided by y, that's going to be 2 point something 2.3 something, right? 2.333, I believe, and that will get stuck into Z, right? Yeah, 2n. Anyway, so that's going to be stuck in there just like the thing. Now, one way to do the C is, it's again, the integer is exactly the same for multiplication, subtraction, addition, subtraction, and multiplication, just like you'd see here. There wouldn't be the decimal place after them, so it'd just be 10, 4, and 21 without any decimal place with them. But here, when I do integer division, I have C is assigned the value A divided by B. What's going to be different there? Well, since I know that there's no fractional part of any number in an integer, then I should realize that, or I can realize that when I divide A by B, I have to go back and just put the number in there without a fraction. So if we look over here, if I divide 7 by 3, I look at here and I say 3 goes into 7 how many times? Well, 3 goes into 7 2 times. 2 times 3 is 6, and 7 minus 6 is 1. Well, I can look at this guy, and if I was going to do the whole thing, I could then bring up that 10, and then I do this 10 here, and I do 3 into 10. That goes 3 times and so forth, but I don't. All I want to do is I want to look at just the answer here. The division answer is just a 2. So in this case here, when I do C is A divided by B, all I'm going to get is a 2. Not 2.33 like I did with the floating point division. I just get the 2 because it's integer division. And there's no fractional part in an integer. Okay? Now, what if I want the fractional part? What if I want this 1? Well, lo and behold, I thought about that, and this modulus does exactly that. So when I do A modulus B, that says find the remainder of the division A divided by B. So if I look over here again, 3 goes into 7. 7 divided by 3, 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. Well, that's the end of my division. So I just look at this 1, and that is my modulus. The 2 is my division. So when I do that, C is assigned the value A modulus B, that gives me my remainder. Okay? Now, you might imagine that you would want to do that with a floating point number, but you can't, because there is no fractional part. I mean, the fractional part is here. You could change these guys to integers and then do that, but that's a different story. You want to go ahead, you can only use the modulus on integer variables or constants. So, there you have it. Those are the simple math operators that we have. Understand too that the order of operations does apply here as well. If you want, you could just call this PEMDOS, because parentheses, exponents, multiplication, modulus, division, addition, and subtraction, that is the order of operations in our math. Well, PEMDOS without the extra M in there is math, and with the other M in there is for computer programming. We haven't learned how to do the exponent yet. Understand that that's going to be done with the function, which we'll talk about later, but PEMDOS is still the order of operations that we need to make sure. If you want to change the order of operations, if you want an addition to go before a multiplication, you have to use parentheses to do that. Oh, and one other thing, there are no implicit multiplications in programming of any kind, at least not that I know of, for sure not in Java. If you want to multiply and you have parentheses, you have to make sure you put that multiplication symbol in there. Something I've seen over and over again, and I still sometimes miss it, just like some of you will. So, so there you have it. A little bit of math operations. Again, our math operators, multiplication, division, modulus, addition, subtraction. We have our assignment operator. Then we have our compound operators with our multiplication assignment, a division assignment, modulus assignment, addition assignment, subtraction assignment, and our operators of plus plus and minus minus here to just add 1 to our variables. So those are some initial math things that we can do, and we'll use them to great advantage as we program more and more. So thanks for tuning in. We'll see you next time on Java with Miyoshi.